So in this video, I'm going to show you how to create your own Spark streaming application, specifically Spark structured streaming. We're going to use Kafka as a source for some streaming data and then transform it within Spark and then push it out to a Cassandra database. So before we get started, I guess we can just kind of show you what I'm thinking about. So this might not be a perfect example, but I thought it can work just for the sake of messing around with these technologies. So I was thinking I'm going to create some like mock IoT devices that are sending out some data. So it's going to be like a weather sensor maybe. So we're going to send out some constant weather data from these IoT devices into our Kafka broker, to our Kafka server. And this will be the source for our Spark streaming application, which will take that data, transform it, and then put it into Cassandra. So that's the basic layout. In this video, we're just going to do some like practical applications and writing the code. I'm not going to really cover the concepts of Kafka or Spark or Cassandra, so you should understand the basics of that, or else you'll be a little lost maybe. As for stuff we need getting started, you will need Java installed, so just make sure you have that. On Ubuntu, I just use the OpenJDK 8 JDK. That's the package that I usually install. Usually works fine. You'll also need Python, so I have Python 3.6. And then just to make things easier, if you have a terminal emulator that can do multiple tabs and split screens and stuff, that'll be nice because we're gonna have a lot of different things open. All right, to get started, we need to download some stuff. So just open up your browser. If you just search Apache Kafka download, you'll find this page. Here's the download right here. And then you can just grab one of these links and just download that. For Spark, same thing, just search Apache Spark download. I'm using 2.4.5, pre-built for Hadoop 2.7. You can use whatever you feel comfortable with, but download link is right there. You also need to download SBT. That's the Scala build tool that we're going to be using to package up the code. So again, just look for SBT download. This is the one that I chose. And then for Cassandra, same thing, search that, it's pretty easy to find, and just grab one of these links. My internet's pretty slow, so I already have them downloaded, and I just keep them, they're just in my temp folder, and I'm gonna just put them into a different folder where I keep my downloaded stuff. So we can go there right now, actually. So here's my opt folder. I'm going to extract Kafka first, we'll start there. So extract temp and then Kafka. All right, so once that is extracted, I'm just going to go into this Kafka folder. I'm going to go back to that Kafka downloads page and just go to their quick start. We're not going to do anything too crazy with Kafka, so just their quick start commands are going to work fine for us. So first, I'm going to start a Zookeeper server. While that's starting up, I'm going to split my window, go back into Kafka, and go back to the quick start and get the command for starting the Kafka server. And while that is up and starting, I'll open another window, back into Kafka, and we're going to make a producer. Or sorry, not a producer, we're going to make a topic that we can produce to and consume from. So like I said, we're going to do, for this example, some IoT devices sending weather data. So I'm just going to call this topic weather. Oops. And to make sure that that went through, I'm going to get this command that will list out our topics. And that shows weather is a topic, so good to know. I'm just going to leave this running and open up a new window. So our next step is, let's go back to our folder. What did I call it? Stream. Yeah, so this is just an empty folder you can make. It's probably good to keep organized. Right now it just has that little layout thing I wrote. So we have Kafka running. Now we need to make some IoT devices. IoT devices with air quotes. It's just going to be Python code that's mimicking a device that is going to produce data into this Kafka cluster. So before we do that, make sure you have, I already said make sure you have Python, but you will need to pip install Kafka-Python. And I already have this installed, so it's not going to show much. But let's see. Let's just open VS Code or another editor you have. And I'm going to make a new file just called IoT devices.py. And since we're not really focusing on Python necessarily, I'm not going to spend the time to actually write this from scratch. Instead, I'm just going to copy it in. And this will be in the repo, so you can just grab it from there. But just a simple explanation is we're using Kafka Producer. In this example, I'm saying we have like 3 different devices in 3 different cities. Each of those cities have like a different range of temperature, humidity, and pressure. And then we're just going to use like a normal distribution to kind of simulate just some actual weather data, even though this is very made up. But it is still good practice. So anyway, we make our producer right there, create some fake data. This is the format of the data. We're going to have a timestamp, the profile name, so whether it's Boston, Denver, or Los Angeles, temperature, humidity, and then pressure. And then that just gets sent to the Kafka producer. Or sorry, it gets produced to the Kafka cluster. So let's make this executable just to make this a little easier. And then I'm going to split this and go into Kafka again. I'm going to go back to that Kafka quick start and grab just this consumer code. And instead of test, we want it to be weather. And we can just start that. So if you run the IoT devices file, you should get an error if you don't provide it with a valid name, one of those cities. So I'm going to say make some weather data from our Boston device. And that says it is sending to Kafka, and we can actually see it coming through on our little consumer. So perfect, that works. Our Kafka server is working. So we are good for that step. So now, the next step, which is kind of the main portion of this whole thing, is the actual Spark application. So just to keep things organized, I'm going to make a folder for the Spark application. Just call it maybe a stream handler or something. Let's go in there. And then I'm going to first just create a build.sbt. This will create like or hold our settings for our build. And then I'm just going to make a folder that has source main Scala. And then inside source main Scala, we'll create our main file called streamhandler.scala. You could use a SBT template if you want, but it's pretty simple to just write it from scratch too. I probably didn't need to open that. I think I already had this open. Oh no, you're right. Do I already have it open? Oh, there we go. Okay. So, so here's the IoT devices, and then inside our stream handler, we have our build SBT and our source where our main file would be. So those are obviously empty right now. We can start with the SBT and then move on to the stream handler Scala. But before that, I realized we actually haven't set up Scala or Scala Spark or SBT yet. So let's go back to whatever folder you were keeping your Kafka in, or it's really up to you where you'd like to put it. So I'm going to extract those things that we downloaded. So temp SBT, we'll just extract that. And then also Spark. Okay, so now we have Spark and Scala, or you can ignore the Scalas from something different. I meant to say Spark and SBT. I'm going to just rename this just Spark to keep it simpler, mostly because we're going to want to add this binary folder for SBT and the binary folder for Spark to our path, just so we don't have to specify the full path each time. So to do that, let's go to wherever you have your profiles at. So I'm going to export path, just like this, and append it onto the old path. So opt spt bin, and just copy and paste, because we're also going to do Spark. Okay, and just make sure you run that to save the changes. Okay, sweet. Let's test it out by doing Spark shell. So this is like the interactive mode for using Spark. If you haven't used Spark at all before, this is like probably the best place to start, just because it kind of creates some of the context for you, connects to Spark, imports the necessary stuff, just like the basic stuff to work with, and it's interactive, so you can kind of see behind the scenes a little more than just writing code and then packaging it up first. This also reminds us we're using 2.4.5 and using Scala 2.11.12. So before we forget this number, I'm going to copy that and go to my SPT folder, or not this one, I'm in my build.spt, and do Scala version 2.11.12. We can exit out of this by just doing Control D. But before we move on from this, we should go into the Spark folder, go into the conf folder, and then change this log4j properties. Instead of actually changing it, we need to just copy it and just remove template. And then let's edit this properties one. So I'm going to change every time it says info. I'm just going to change this to warn. This will just make our console look a little cleaner. And I forgot the find and replace command for Vim, so I'm just going to do this by hand, but it's okay. There's only 3. So now this will just make reading our output a little nicer. If you don't do it, that's fine. It's up to you though. Okay, so let's go back into that folder we got going, and we can go into our stream handler again. I'm going to open up this code and look at our build SPT. We have our Scala version. We can also add a name. Let's call it stream handler. We can add a version. And then we also need to specify our library dependencies, which I always have trouble spelling, so hopefully that's right. So we'll come back to this more, but we can just add the basic ones right now, which is Apache Spark. We need Spark Core. We keep missing that one. And 2.4.5 is our Spark version. And since this is part of Spark, we can actually save some time by just saying provided. Since we are doing Spark structured streaming, that's kind of based off Spark SQL, so we do need to specify that dependency as well. All right, so now we have our build SPT set up. We have our stream handler file made, nothing in it yet. We have Spark and SPT on our path, so we will be able to run those commands. So now we're actually ready to start writing the Spark streaming application. So first, we can just start by importing the necessary stuff. So we have apache.spark.sql. And then we need SQL, or sorry, not capitalized, SQL functions. And we need Spark SQL streaming. We also need types. And we'll need some more stuff later, but those are kind of the basics for right now. So we can set up our main object by doing Spark or object stream handler and our main method. All right, so now we're ready to go. First thing we need to do is actually initialize Spark. So we're going to say Spark equals Spark session, which Spark session is coming from this import statement up here. And we'll do the builder method. with the app name. Let's call it stream handler again. And we'll do get or create. Okay, with our Spark session initialized, we actually need to import Spark implicits. This will help us avoid some warnings. Now we can define our input data frame. So this is going to be the data frame coming from Kafka. And because we are doing structured streaming, this will be formatted as a table, which is nice. So we'll do Spark read stream format Kafka. We also need to kind of set up some options here. So the Kafka bootstrap servers. And if you have more running, you can just provide this with a list. But we're just doing a pretty basic one, so we just have that standard one up and running. And with that, we can load. Oh, actually, no, I did forget to subscribe to the topic. So option, subscribe to weather, which is that topic we made. All right, so with that set up, before we move on any further, we should just complete the whole streaming cycle. So we're going to say query is equal to our input data frame. And this will be a write stream. Output mode, we'll just set it, output mode, set that to update. And then start. And another thing I forgot, sorry, is to format console, because we just want to print this out to the console while we're debugging. And to get this running, we say query dot wait termination. So we initialize Spark, we read from Kafka, and then we just print it out to the console. All right, so now that we have our basic Spark streaming application written, let's head back to the terminal and get ready to submit this to Spark. So before we do that, we need to pack it up as a jar file. So we're just going to run sbt package. SBT should work for you if you added it to your path and extracted it and everything. So this might take a while, so I'll just fast forward through this part. All right, so our SBT package command succeeded. So we do have a jar file that is located in target Scala folder. So if you just double tab right there, you'll see we have our stream handler jar, which is what we're going to submit to Spark. So to do that, we actually just run the Spark submit command. You do have to specify the main class name, and ours is stream handler. You also need to specify how we're deploying it. We're just doing a local deploy, like we're not connecting to Yarn or Mesos or anything. So I'm just going to say local star, just use all the cores you want. You do need at least 2, just for your information. And then we can do target Scala and then our jar file, which is stream. So that is the Spark submit command. And most likely this is going to fail because it failed to find the data source Kafka. So they say you can go to this webpage right here to get some information on it. But all we really need to do is add the packages switch and just specify the artifact ID or the coordinates for the artifact for Kafka. And more specifically, the connector between Spark and Kafka. So that's in Apache Spark. We just do a colon, and it's Spark SQL Kafka. We're using version 10, and this needs to work with Scala 2.11 and Spark version 2.4.5. All right, so this should fix that issue. And it looks like it is up and running. We're not getting any more output. So I'm actually going to open up a new window right here, go back into our project, and let's start our IoT device. And we're going to say for Boston. So now we're sending this data to Kafka, and it looks like this data is coming through to Kafka and into our Spark application. So that's good news. If you do look at this closely, these are all the same. It looks like this is probably the hex value for Boston, because that's our, or maybe not Boston, I think time comes first. Anyway, this is just hex value, so we don't really want to work with that. So let's go back to our Spark application and keep on working. Now that we know that it is, the basic building blocks are there. So first, maybe we should have our raw data can just be like our input data frame, and we're going to use the select expression, and we're going to cast value. So if we remember, our table is value, this is where our actual data is. We're not going to worry about partitions or offsets or topics. We're keeping it pretty simple. We're just worrying about the value coming over from Kafka. So we're going to value as a string rather than that hex codes. Okay. And then we'll also just map this whole thing as a string. So now our raw data frame will contain, it's just going to be a table of just one column called value. So if you remember, we actually have multiple columns, right? We have like our device name and then temperature, humidity, and pressure and stuff. So just to keep everything straight, I'm going to actually go up here and just write a simple case class. So case class, device data, and it's going to be like the device name. We're going to have the temperature, the humidity, and the pressure, and those are all doubles. So now let's do, so like I said, we could just put this raw data frame here and print it out if we want to look at it again. That's what I did as I was first messing around with this example, but that would just be too much waiting for the SBT package and the Spark submit. So just trust me on this one. We're going to expand this row, that one column value, into a bigger table. So we're going to do like that raw data frame, and we're going to map for each row. We're going to split that row on a comma. So I guess just to visualize this a little bit, right now we have like value looking like something like that. So we need to split this into an array that is splitting on these commas. So if we split on that, then for each of those, we're going to map those rows and then create a new device data object or container or whatever you would like to call it. So we're actually passing over this timestamp, and that was just for fun, I guess. We're actually not going to worry about it. So the first thing we want to put in is our device into the case class. So that's our row. That's the first thing going to be in the row. And then we have row 2, row 3, and row 4. And just like that. And this is our ending parenthesis for our device data, and that's the ending for our map. Okay, cool. So maybe now is a good time to test it again. So we're going to query the expanded data frame and print that out to the console. So I'm going to go back here. I'm actually going to combine these commands, so SBT package and Spark submit, just to make things go a little quicker. And again, I'll probably just speed through this as it's taken its time. Okay, it looks like we have a type mismatch because we're passing in strings to doubles. That's a very simple mistake that I completely forgot about. So Let's just do that to double. Okay, that should fix that. Let's try it again. Okay, it looks like our package built and the streamer is now listening. Let's start up that IoT device again. So now it's sending that data over. Let's give it a sec. All right, okay, that's looking a little better. I'm gonna pause this. So we split up our table into something we can work with more easily. So we have device, temperature, humidity, and pressure. All right, so now that we know that our expanded data frame is showing up correctly, we're ready to aggregate it a little bit. And like I said, it's a little contrived that we're just aggregating our data frame, but just some more experience with the Spark SQL. And ideally, if this was a more refined use case, then we probably would have a reason why we would want to aggregate by a certain column for each batch. Anyway, so to make our new data frame that will contain our aggregated values, we can just say just summary df is our expanded df, and we're going to group by device, and then aggregate, we'll just get the average of temperature and of humidity and of pressure. Okay, let's just double check this works, because if this works, this will be almost our final form for how we're going to put it into Cassandra. So all right, it looks like we have our blank data frame. So I'm going to start running the producers. Let's give it a couple seconds because it looks like it has been getting behind. Awesome. So we have Denver, Boston, Los Angeles being aggregated by our 3 columns. So this will be the data we want to be storing in our Cassandra cluster. So I'm going to cancel those, stop that. Okay, before we add on to this code to make it work with Cassandra, we better set up Cassandra. So let's hop over to the terminal there. So let's just open up a new window, go into the op folder, and extract Cassandra. I think it's maybe Apache Cassandra. Oh, there we go. All right, so into Apache Cassandra, I'm going to split this. All right, and then I'm going to just run Cassandra in the foreground with the -f. And like I said, I'm not doing anything too crazy. I'm just going to be using the simple default settings for the Cassandra cluster. We're not probably going to be using Cassandra correctly, doing multiple nodes and everything. This is just for messing around. So I apologize if that bothers you. So we're going to do node tool status. See if that node is up. Looks like it is. Awesome. So we can do bin and get into the SQL shell. So let's describe key spaces, or do I do the key? I spelled that wrong. Key spaces. There we go. So we got no key spaces yet. So we can create a key space. So create key space. We'll just call it stuff. Like I said, we're not really doing this correctly because we're just going to do simple strategy with no replication. I need quotes. Strategy. One. Okay, cool. Let's use this key space. Now we need to create a table. We can just call it weather. we can give this a UUID with type UUID. Shoot. I meant to say UUID primary key. There we go. The device name will just be a text. Then we have our temperature, which is a double, humidity, which is a double, and pressure, which is a double. Okay, so we can select star from weather. Got nothing there, but we can kind of see our schema. So that's kind of all we need to do for Cassandra setup. Like I said, we're not really doing a very well thought out partition key or clustering columns or anything like that. This is just for extend this example a little more than it already is. All right, so we have Cassandra all set up. We can double check our table, which we made is called weather. You can see it is empty, and we have this column UUID, which is a column we don't have in our Spark data frame yet. So that is important to remember. As we start to integrate our Spark app with Cassandra, we need to add that column. So first step we can do is add some configuration stuff. So Spark, Cassandra, connection host. And that's just going to be localhost. Obviously, there's a lot more configuration we can do and we need to do depending on our situation. While we're up here, we can just take care of some imports. So we have org. I guess I can just copy from above. Instead of types, we're going to do Cassandra. And then we do need some stuff from data stacks. So I'm going to do com data stacks driver API core UUID. So this is going to help us make some UUIDs for each little row we're going to be putting into the database. And we also need the data stacks Spark connector. Okay, so we have our imports. We've got this. Now we just need to transform our data frame a little bit. Like I mentioned, we need to have some sort of function that will help us make some UUIDs. So we're just going to use this UDF, which is a user-defined function. It's part of Spark SQL. And so this is just going to be that UUIDs. We're just going to make a time-based one using that data stacks UUID little utility they have. So because this is a UDF, it's going to return a column, which will make our transformation really easy. We'll just call this summary with IDs. And this is going to be an expanded data frame with, or not, sorry, not the expanded one. We want our summary one. With column, we will call it UUID, and we're just going to run that function. And that'll give each little row its own UUID, which will be perfect. Okay, so we now need to change this to here. Now, if we were to test this out, I'm pretty sure this will work. I guess since we are importing some stuff, maybe it is a good time to test it out. So let's hop back over. Okay, so now instead of just Kafka, we need to include some of that data stack stuff. So this will get a little messy. Maybe it would be smart to put this in a different file or organize it a little differently, but we will just go for it. So it is com data stacks.spark colon Spark Cassandra connector 211. And this version, they don't actually have for 2.4.5 yet. So the latest one is 2.4.3. And then we also need com data stacks Cassandra. And this is what allows us to use a UUID. So Cassandra driver core. and that's 4.0.0. Okay, let's give that a try. So we're not really connecting to Cassandra yet, but since we've already put in those imports, we can see if they are working correctly. And it looks like that failed, and it's probably because I forgot to add that to the build SBT, which I often do. So sorry for that. Let's add that real quick. Spark. And this is Spark Cassandra connector 2.4.3. And then the other one is just data stacks Cassandra. And this one is actually 4.0.0. Okay, let's give that a try. Hopefully that fixes it. Okay, it looks like we're running. Let's start a producer and see if those UUIDs are being correctly made. Okay, awesome. We have that one and our averages. It looks like that's a different one. So it's looking like it's working. Awesome. So we can cancel this. And okay, so we have our imports, we have our configuration. This data frame is in the correct format that we will be pushing to Cassandra. It matches up with the schema. So now we're actually ready to do the writing. So we still want to write stream, we still want this trigger, but instead of, we obviously don't want format console anymore. And then we're going to do something a little different right here. So we're going to do for each batch with, there's going to be a batch data frame of type data frame, which data frame's imported from Spark SQL. So we have that. And then they also come with a batch ID. And just for logging purposes, we can do a little print line. Maybe just say, writing to Cassandra. Something like that. Okay, and then we want our batch data frame. And then we're going to write, not write stream. Oops. And then Cassandra format. So now this is where we say the table name, which is weather, and then the key space, which we called stuff, and then the mode, where we'll just put append and then save. So the reason we have to do this whole for each batch is just because this Cassandra format, mode, save, all this stuff is only tied to this write. I don't think there's support yet to do this with the write stream. So we just have this within a little for loop. And then we still have this outer output mode and start. So actually, before we run this, I realized that our data frame doesn't match the schema exactly. After we run these aggregations, this column will be called average temperature and average humidity and average pressure and so on. So we actually need to quickly do some with column renamed on those. So we want average temp to just be called temp and so on. So it's a pretty quick fix. That's pressure and that's humidity. All right, so now the summary with IDs will have the correct column names. So now we should be ready to hop over and run this. And I've got my producers all ready to go. All right, it looks like it's saying writing to Cassandra 0, meaning it is, well, writing nothing right now. So we can start the producers. And let's see how this goes. It might be a little bit behind. Yeah, it looks like it's giving us a warning, but it is writing to Cassandra. Let's let it write one more time, and then we'll go check the Cassandra database. All right, let's hop over there, do select star, and look at that. We have our UUIDs, our cities, and our values. So looks like I wrote some more, and just like that, we are slowly streaming in data from our Python producers into Kafka through Spark and out to Cassandra. So I've already said this a million times. This might be kind of a weird example, and I might not be using these technologies correctly in the way they're designed, but hopefully it was useful in some way, and hope you enjoyed watching. So thanks.